Batrachoididae is the family of ray-finned fish that are usually called toadfish or frogfish. Both the English common name and scientific name refer to their toad-like appearance, where batrachos is Greek for frog. These fish favor sandy or muddy substrates, where their cryptic coloration helps them avoid detection by their prey. A perfect adaptation for their scaleless bodies, with eyes set high on large, ugly heads to ambush their prey. Even though toadfishes are found worldwide and are mostly marine, one species, native to the eastern Pacific Ocean, extending along the coast from Sitka, Alaska, to Magdalena Bay in southern Baja California, has caught the attention of unsuspecting residents for years. Porichthys notatus, or commonly known as the plainfin midshipman. With a face only a mother could love, this little creature caused quite a mystery for houseboat residents in Sausalito, California in the 80s. And all the fuss was not about its looks, but rather the sound it made. For years, these residents complained about a droning hum from San Francisco Bay on summer nights. The sound was so loud that it could drown out conversations or disrupt sleep. Theories for the mysterious sound included sewage pumps, military experiments, and submarines. Ultimately, it remained a mystery for nearly a century, until scientists discovered that this little creature was the one causing all the buzz. For much of the year, you won't hear these fish singing at all, as they reside in the depths of the ocean during the fall and winter. But during the spring and early summer, they move to coastal waters, where the males build nests beneath rocky shelters. From there, the male fish sing to attract mates, a sound that can be heard by humans on shore. But these vocalizations aren't spontaneous. Instead, they're controlled by the fish's internal clocks, which is why they happen exclusively at night. And the hormone that controls these clocks is the same one that regulates bird activity and human sleep patterns. To sing, a male plainfin midshipman produces sound by vibrating a gas-filled bladder within the abdomen. Each hum would draw the females to the nest he has prepared, where the sound can last up to 2 hours, and when the males hum together, the sound is amplified. Scientists caught a number of wild male plainfin midshipman fish and kept them in labs where the brightness could be controlled. They found that when the light was constantly bright, the fish did not secrete melatonin and did not hum at all. With bright light, fish given a melatonin substitute would hum, but at random times, suggesting that the humming is a reaction to melatonin. In nature, when it goes dark, a plainfin midshipman fish's melatonin levels rise, waking him up and causing him to sing. However, melatonin has the opposite effect on birds and mammals that are active during the day, as it helps them stay quiet and fall asleep. But the study establishes that the same hormone is the driving force behind circadian rhythms across nature. As for these plainfin midshipmen, reproductive females respond to the humming by choosing a singing male's nest and depositing all of their eggs for that season in that nest. Hoping to lure more females, the male resumes singing after a female's departure, while actively guarding his nest until the offspring hatch and mature. He will hum until his nest is full of multiple clutches of eggs, where a single male may fertilize and guard as many as 1,300 eggs. Despite the ability of both males and females of the species to produce sounds, only some male midshipmen can hum in a singing way. These are called type 1, or parental males. These fish excavate den-like nests beneath rocks in the intertidal zone, guard their nests, and hum to attract females. Type 2, or sneaker males, are smaller than type 1 males. They do not build nests and cannot sing. Unable to attract females, they hang around the nests of humming type 1 males and quickly dart into that particular nest when a female enters in order to fertilize her eggs. However, The conditions of the intertidal breeding habitat change regularly with the tide. In fact, a male tending to his nest can become stranded as the tide recedes, even becoming completely beached out of the water. Luckily, the fish tolerates this well. It has the ability to breathe air and is physiologically well adapted to hypoxia as well as hypercapnia. In fact, even its sperm remain quite functional in low oxygen conditions. But surviving the harsh conditions of the intertidal zone is only part of the story, because life in these shallow coastal environments comes with another challenge: constant exposure to predators. From above, seabirds patrol the shoreline, scanning for movement in the exposed pools. From below, larger fish lurk in deeper channels, ready to strike when the tide returns. And yet, the plainfin midshipman remains, relying not on speed, but on stillness. Its mottled, mud-colored body blends almost perfectly with the rocks and sediment. Motionless, nearly invisible, it waits. This strategy, ambush and patience, is what defines much of its existence. But what truly sets this species apart isn't just how it hides, it's how it communicates. Because the hum of the midshipman is not a simple sound. It is one of the longest duration vocalizations produced by any fish. And to sustain a hum that can last for hours requires something extraordinary. Inside the male's body, specialized sonic muscles contract at incredible speeds, up to hundreds of times per second, causing the swim bladder to vibrate like a drum. These muscles are among the fastest known in the vertebrate world. Built for endurance, they can maintain this rapid contraction for extended periods without fatigue, something most muscles in other animals simply cannot do. And when dozens or even hundreds of males begin humming together along a coastline, the result is something almost otherworldly. A low, continuous drone that fills the night air. To human ears, it can sound mechanical, almost artificial. But beneath the surface, it is a chorus of competing signals, each male trying to outlast and outcall the others. Because in this underwater symphony, persistence matters. The longer and more stable the hum, the more attractive the male appears to potential mates. It is not about volume alone, it is about stamina, consistency, control. And in a world where visibility is limited, sound becomes everything. But not all females respond the same way. Research has shown that females are highly selective, often choosing males with the most stable and continuous hums. Subtle variations in frequency and duration can influence their decisions, suggesting that these fish are capable of detecting fine acoustic differences. In other words, this is not random noise. It is a highly tuned communication system, shaped by evolution over millions of years. And yet, despite all this, the life of a midshipman is far from peaceful. Two completely different approaches to reproduction. One based on attraction and endurance, the other on stealth and opportunity, both existing within the same species, both driven by the same goal. And as the tide continues its endless cycle, washing in and out, the rhythm of their lives follows. Night after night, the hum returns, guided by darkness, driven by hormones, echoing across the water, until eventually the season ends. The males fall silent. The nests, once filled with life, are abandoned, and the fish retreat once more to deeper waters, but not gone. Because with the return of spring, the cycle will begin again.